Set of squares is the square root. And that looks like this. Where this little thing, that is not a division sign. That is what we call a radical sign. It's radical. And the little number down here is actually called the radicand. And the square root of 36, you have to ask yourself this question. To find the square root of 36, you ask yourself, what number times itself gives me the radicand? There is no easy way to do these. It is mostly one of the rare times in math it's just like trial and error. The square root of 36, you just have to ask yourself, what number times itself will give you 36? In which case, Carter says 6. Okay, what about the square root of 9? What is the square root of 9, Brian? 3. How about the square root of 7? What number times itself will give you 7? Amelia?
3.5.
No. Actually, 3.5 times itself. Let's do that. What is 3.5 times 3.5 actually is 17, 0, 15, 1, 9, 10. It's actually 5 to 12.25. Not 3.5 times 3.5. 3 times itself is that. Now, that's kind of a trick question because there is no perfect square to that. As a matter of fact, the square root of 7 is what we in the math world call irrational. You can tell what it is kind of closely because it's between the square root of 9 and the square root of 4. It's somewhere between 2 and 3 is the answer. But there is no what we call perfect answer to that. And that's the way it is with most square root things, except for what we call the perfect squares. And if you go back to that screen or the notes that you took here where we wrote down all of these are the only numbers that are going to work out when you take a square root of them because it's that same number. For example, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. These are the only square roots that work out from 0 to 100. Everything else in there, if you try to take its square root, you get a decimal that never ends if you try to figure it out. And again, that doesn't mean that we can't get close. Okay, for example, if I said the square root of 18, the square root of 18 would have to be between what two numbers? Well, you look at where the square root of 18 falls between our perfect squares, and the square root of 18 has to be between the square root of 16 and the square root of 25. So the square root of 18 has to be between 4 and 5 somewhere. You know, if I gave you the square root of $18, it's somewhere in a little over $4 or less than $5. And that's the best we can do right now, especially you guys as sixth graders. You know, if I said the square root of 71 is close to what? What whole number would the square root, what two whole numbers would the square root of 71 be between? Wade?
81 and 64.
Right, so it'd be between these two whole numbers. If I gave you the square root of $71, you'd have somewhere between $8 and $9. So squares are tough to think about because there's only certain ones of them that work out perfectly. The rest of them are what we call irrational. They don't make sense because they end up being decimals that go on forever and forever, as the date would have there. Let's see what else they give you there. The rest of that stuff, I think you should be kind of good with. They do talk about